Welcome to Engage Math, Lesson 19, Problem 4. So in this situation, we are looking for a perfect square trinomial. And what value of k would make this a perfect square trinomial? So I took the liberty of writing above Problem 4 the two factoring patterns that you will see on the inside back cover of your workbook. And this is just to kind of remind you of what a perfect square trinomial looks like. So in order for us to have a perfect square trinomial, the square root of the x squared, which we know is x, and the square root of this last term doubled has to give us the middle term. So the square root of x squared is x, and we have to figure out what number we can take the square root of so that when we double it, we get a 20. And the way that that will happen is the easiest way to look at it is to think of taking half of that middle coefficient, which is often referred to as b, ax squared plus bx plus c, and square it. So in this case, we're going to take half of negative 20 and we're going to square it. And half of negative 20 is negative 10. Negative 10 squared is 100. So the value of k should be 100. So now watch how nicely this works. If we say x squared minus 20x plus 100, at this point, what we can see is that we have made this trinomial into a perfect square trinomial because it would factor as x minus 10, the quantity squared. And I'm going to get rid of that line there. I just don't want you to think that's a division line. So what's really nice, though, is we have a very kind of straightforward method to figure out what that last term, that third term, needs to be so that it's a perfect square trinomial. And it is. Okay, let's go to B. It's a little bit tougher. By the way, one other thing on this, k is equal to 100 was our final answer. This work that I did here was just to show you that it does work, that our answer is correct. Okay, let's go to the next one. Now, keep in mind that we already know that if we have a perfect square trinomial, the square root of the first term times the square root of the second term, the square root of the third term doubled has to give us the middle term. So the square root of the first term is 2mp. The square root of the last term is 3n. If we were to multiply those together, we would get 6m and p. I'm just going to put it in alphabetical order. And if we doubled that times 2, that would give us the middle term if it's a perfect square trinomial. So I'm going to change, you know what, I'm going to change that x to a dot so you don't think it's a variable. So it's this times 2. So we know that that's going to be 12mnp. Oh, I said it the right way, but I kind of put the p second. So let me redo that. So 12mnp should be what our middle term is. So let's just look at that for a minute. If we say that k is 12, so 4m squared p squared plus 12mnp plus 9n squared, that would mean that k is 12, which is what we kind of figured out right here. And if k is 12, look how nicely that's going to work, because now we can see that this factors as 2mp plus 3n, the quantity squared. And it's now a perfect square trinomial, because you could try it, but if you multiply this out, I would guarantee you'll get the first term, the last term, and then the middle term of 12mnp when you combine your two terms, your two middle terms. Okay, but here is the thing. Even though we know that k is 12, like that's an answer, we have it. We also know that what if it was the difference right here? Instead of a sum, instead of an addition sign, there was a minus sign. Well, that works as well, because if k was equal to a negative 12, everything would be the same except for we would have this sign right here would be a minus. So really that middle sign could be either a plus or a minus, and k could be either equal to a positive 12 or a negative 12. Great. Thanks for joining us here today at Engage Math.